Good afternoon, class. We are looking at module 2, covering chapters 3 and 4. Chapter 3, functions. Chapter 4, linear functions. And let's put this in slide mode. Here's chapter 2, chapter 3 and 4, functions. Dependent and independent variables. So we're going to look at some definitions. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. In short, the first one is independent, the second one is dependent. Normally, x is the first, y is the second one. And now we want to look at meaning of a relation, domain, and range. A set of ordered pairs, any ordered pairs known as a relation. Domain, the set of all input values, x values or independent variable for a relation. So along the x-axis, so you can see the domain here, all possible values of x. Range, the set of all output values, y values, dependent variable for a relation. So here's the range along the y-axis, all possible values of the dependent variable y. A function is a relation in which each element in the domain corresponds to exactly one element in the range. In other words, the x coordinates cannot repeat. And to show that, we can use VLT, the vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent a function. If not, then the graph represents a function. So you can't come up with a vertical line that crosses the graph more than once. If it does, it's not a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. In other words, not only the x coordinates cannot repeat, now the y coordinates cannot repeat either. And now we're going to use HLT, horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. In other words, you draw a horizontal line. If it crosses more than once, you no longer have a one-to-one function. All right. How do we find the domain for a rational function? In general, we set the denominator equal to 0 and we exclude that. Two x minus 1 is 0, x is 1/2. That means everything is acceptable except 1/2. So how do you show that? There are two ways. This is the shorthand notation. X can't be 1/2. And this is the interval notation. Part B, the square root of 5x plus 4. And just going back, this negative infinity to 1/2 union 1/2 to infinity. Notice with the parentheses, we're getting rid of 1/2. 5x plus 4 is larger than or equal to 4, which means 5. Let's just move the 4 and make it minus 4 here. Divide by 5. X is larger than or equal to negative 4/5. This is the inequality, and this is the interval format. The last one, the answer is all real numbers because it's a polynomial of degree 2. More specifically, it's a quadratic function. So any polynomial the domain would be all real numbers, negative to positive infinity. There is no restriction. Now, polynomial of any degree. This is the polynomial of degree 2. What about cube root of x? It is also all real numbers. Why is that? Whenever the index, you're looking at a root function, when the index is odd, then there is no restriction as far as the domain is concerned of real numbers. And by all real numbers, we mean either just R or from negative to positive infinity. Again, we are dealing with a rational expression. We set the denominator equal to 0, x squared minus 1 equal to 0. X becomes plus minus 1, and we exclude that. So the domain is this. Or in an interval format is this. Negative infinity to negative 1 union, negative 1 to 1 union, 1 to infinity. This means exclude positive 1 and negative 1. This is a shorthand notation or inequality. This is the interval format. And many times we are interested in the interval format. This one, again, the answer is all real numbers because it's a polynomial of degree 1 or a linear function. So you can say linear function. Or as I mentioned, polynomial of degree 1. The graph is given. We want to see if it's a function, if it's a one-to-one function, and we want to find the domain and range. Is this a function? Yes. Is this a one-to-one function? Yes. Why is that? It's a function because it passes a vertical line test. What does it mean? If you could draw any vertical line that crosses the graph more than once, it fails to be a function. We can. If you could draw any horizontal line that crosses the graph more than once, it won't be a one-to-one function. So it passes. So this one, because it passes VLT, the vertical line test, and this one because it passes HLT, horizontal line test. And so with that being the case, we want to go for the domain. So what is the domain? Notice that this point will give us this point will give us this, and this would be the domain 2 to 8, where 2 is not included. Use a different color for the range. So for the range, 6 is included, 8 is not, and the range is 6 to 8. Again, we want to pay attention to the meaning of parentheses versus bracket. 2 is not included, 8 is included. 6 is included, 8 is not included along the y-axis. So that's important to understand. Is this representing a function? Yes. Can you come up with a vertical line that crosses the graph more than once? No. Yes, it's a function. But look at this line. If I draw this line, a horizontal line, it fails. Is it a function? Yes. Is it a one-to-one function? No. So it fails the VLT and it fails the HLT, and therefore it is not a one-to-one function. What about the domain and range? Let's find out. So this point here, and here's the last point. You see the hole here. So it goes from -3 to 2. Is -3 included? Yes. Is +2 included? No. What about the range? This is the bottom. This is the top. From -5 to +4, and the endpoints are both included. Part C, is it a function? No. Is it a one-to-one function? No, because it fails the vertical line test as well as the horizontal line test. So this vertical line, for example, you see that these 2 points have the same x coordinates, as an example. Now, as far as the domain and range is concerned, it's pretty simple. Here's the left side. Here's the right side, giving us from -4 to 0, and both ends are included. And here's the bottom of the graph, this one. Here's the top of the graph, this one. And everything in between from 0 to 4. Endpoints are included. So I hope everybody can see how we arrive at the domain. Here's the function f of x equals 2x plus 1, and we want to simplify, find and simplify this expression. This is known as the difference quotient. So rates of change, the difference quotient delta y over delta x, which is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. This is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. So if you pick up two pairs and connect them, the line is called the secant line, and you know how to calculate the slope. And these are various ways of writing in class. Delta y over delta x, rise over run. Or this one, if you want to go with x sub 2 and x sub 1, you get to this expression, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. If this is a and this is b, if I, instead of a plus h, I put b, gives us this expression. If instead of b, I call it x, it gives us this expression. And if you go with a plus h, it gives us this last expression. All of them, in essence, are the difference quotient. This is most widely used. So let's see what we can do. So we are going to plug in, instead of x plus h, so 2 times x plus h plus 1 minus f of x, the same thing, over h. So I hope everybody can see we just plug in. So again, what is f of x plus h? 2 times x plus h plus 1 minus f of x over h. All we have to do, simplify this expression in the numerator, which means we are going to distribute. We get 2x here, we get 2h here. This is plus 1, this is minus 2x, this is minus 1. And as you can see, 2x and minus 2x cancel each other. Positive 1, negative 1 cancel each other. We get 2h over h, which becomes 2. Given the function f of x equals 2x squared plus 1, we are interested in finding, and g of x equals 3x minus 5, we are interested in finding f of g of 2. So refreshing everyone's memory about algebra functions. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F g of x is f of x times g of x. F over g of x is f of x over g of x. G of x can't be 0, of course. So f plus g is called the sum function. F minus g is the difference function. F times G is called the product function, and this is the quotient function. And the composite function of f of g is f of g of x, g of f is g of f of x. So this is just to refresh everyone's memory as far as what algebra functions are all about. Now, if we are interested in finding f of g of 2, that means we have to find g of 2 first. So g of 2, plug in 2 in here. And so 3 times 2 minus 5, this is 6. Minus 5 or 1. Therefore, we are interested in f of 1. So now 1 goes into this 2 times 1 squared plus 1, and that is simply 3 because this is 1 times 2 is 2. 2 plus 1 becomes 3. We are done. F of g of x. That means into the x, replace the g. F of g of x. F of g or f of g of x. So let's replace this x with 3x minus 5 2 times 3x minus 5 quantity squared plus 1. We're going to square this, and I'm going to remind you again, but a minus b squared, which is a squared, minus 2ab plus b squared. Therefore, we have 3x squared minus 2 times 3x times 5 plus 5 squared. Now this is 9x squared minus 30x plus 25. So that's what we have here. And so 2 times 9x squared is 18x squared minus 60x plus 50 with the 1 becomes 51. So in other words, this last part, I want to make sure that you understand this one and then add plus 1 to it becomes 51. Very straightforward, everybody. All right, we want g of f of x. That means g of f of x. We are continuing with the same question. And so basically it means in this function, replace the x with the f function, which is 2x squared plus 1. That's the meaning. So what do? 3 times 2x squared is 6x squared plus 3. And plus 3 and negative 5, these two combine into negative 2, and we are done. We want g of g. That means g of x, which means replace the x with 3x minus 5. That's the meaning of it. And so into x goes 3x minus 5. This is 9x. This is minus 15. Minus 15 and minus 5 are like terms. They add up to negative 20. So 9x minus 20 is the final answer. F of x is given again the same thing as 2x plus 1. 2x squared plus 1, g of x is given as 3x minus 5, and we want to find f of negative 2, which means f of negative 2, that's the meaning of it, which means first we have to find f of negative 2. We need to find f of negative 2. How do we find that? We replace this x with negative 2. And as you know, this is positive 4 times 2, 8, plus 1 is 9. Therefore, if f of 2 is negative 9, positive 9, we want f of 9. So we are going to plug in 9 instead of x. So 2 times 9 squared plus 1. As you know, 9 squared is 81. So 2 times 81, 162, and 1 is 163. We want to determine if the function f of x and g of x are odd or even, and to do so, we need to remind everyone of the following definitions. A function is an even function if f of minus x is f of x. That means it's symmetric with respect to the y-axis. A function is an odd function if f of minus x is minus f of x, which means it's symmetric with respect to the origin. So all you have to do, replace the x with minus x and observe. So let's do that. So replace the x with minus x. As you can see, minus x squared is the same as x squared. So this is 2x squared plus 1, which is identical to f of x. By this definition, this is an even function. So we're done with f of x. We are going to look at g of x. And we're going to evaluate g of minus x, which means we're going to replace the x with negative x. So as you can see, this gives you minus 3x, and this remains. And as you can see, it is not equal to g of x. It is not equal to the opposite of g. So it's not equal to that. And the opposite of that would be minus 3x plus 5. So it's neither even nor odd. The question was, is it even or odd? And you say it's neither. I want to find the average rate of change of each function in the given interval. When we want to find the average rate of change, I'm going to remind you of what we just put up. Basically, what it says, this is not a pair. You're going to go from A to B, from x of 1 to x of 2. That's the meaning of it. Okay, so if you call this A, you call this B. In essence, you're looking at this one. If you call it x of 1, x of 2, you're looking at this one. So however you want to call that, perhaps it's not a bad idea to go with A and B. So from A to B. So f of B minus f of A, that means f of 1 minus f of negative 1 over 1 minus negative 1. So if I plug in 1 here, I get 3 minus 3 times negative 1. And over here, I get 1 plus 1, which is 2. So I hope you see that. So this is 3 times 1 or 3. And then this is minus is this one. This sign is here, minus 3 times negative 1. So this makes it positive 3. And this gives you 2. So 6 over 2, or 6 halves, or 3 is the final answer. We want to find the same thing but this time from 4 to a for a different function. If f of x is 2x minus 9, we want to go from 4 to a, which means we want f of a minus f of 4 over a minus 4. So first, let's understand the definition, everybody. So what is f of a? 2a minus 9. What is f of 4? 2 times 4 minus 9. So f of a, 2a minus 9. F of 4, 2 times 4 minus 9. And the bottom is simply a minus 4. All we have to do is simplify the numerator. So this is simply 2a minus 9. This is 8 minus 9, which makes it negative 1. And therefore, it makes it positive 1 because negative, negative 1. And clearly, I can factor the I can factor the 2 from the top to get 2 times a minus 4. And we can drop the common factor of 2. So the final answer is a minus 4 for this question. F of x is 3x plus 4. We want to go from 2 to 2 plus h. Therefore, we want to evaluate f of 2 plus h minus f of 2 over 2 plus h minus 2. That's what we want to evaluate. So let's replace the x with 2 plus h and then with 2. If you do it with the 2 plus h, you get 3 times 2 plus h plus 4 in the bracket, minus then 3 times 2 plus 4 in another bracket. And all we have to do, simplify the numerator, because the denominator clearly 2 and negative 2 cancel each other, they give us h. So let's see what happens to the top. So we're going to distribute, we get 6 plus 3h plus 4 minus 10. As you can see, positive 4 and negative 10, they add up to 0. So the numerator is only 3h. We can drop the 3 and h, and we get 3 as the final answer. All right, transformation, you have it. I'm going to give you the synopsis of that. So you have this function y equals f of x. If I write y equals f of x plus c, we are assuming c is positive. Okay, we are assuming c is positive. That means go up by c units. F of x minus c, that means bring this down. Go back to the original one. Bring it down by c units. F of x minus c, shift to the right by c units. F of x plus c, shift to the left by c units. Compression, stretching, reflection. So again, we have this y equals f of x. And we are assuming c is positive. So if we multiply it by c, it stretches by a factor of c. If we put 1 over c, then it shrinks by that factor. Here's f of x. If I put a negative in front of it, it flips over with respect to the x coordinate because the y values are different or opposite. But if we change the x and we put f of minus x, then it flips over with respect to the y-axis. So those are the reflection that we should know. All right. The following function was graphed by applying transformation to a toolkit or essential function. We want to write the equation of the function that matches the graph. First and foremost, here's a bunch of functions we should be very comfortable with and know their graphs. And by the way, f of x or y equals b. That is a horizontal line. Okay. F of x equals x, that means y equals x. That's the line that goes through the origin. Okay, 0, 0, and 1, 1, for example. F of x equals x squared or y equals x squared is a basic quadratic function. F of x equals x cubed, it's a basic cube function. F of x is square root of x, and f of x equals cube root of x. Why is it important to know it? You can do the transformation. You should know the domain. You should know the range. For example, the domain for this one is all real numbers. The range is only one point p. The domain and range is all real numbers for this one. Same thing here. The domain and range is all real numbers. The domain and range is all real numbers for all those three. This one, the domain is all real numbers, but the range starts from 0 and goes to infinity. In this case, domain from 0 to infinity, range from 0 to infinity as well. And here's another one that you should know. It's an absolute value function, which looks like a V shape. This is also one of those essential functions. We should know the graph, which means the domain is all real numbers. See, it covers everything along the x-axis, but the range is from 0 to infinity. And so we are interested in this one. And among those graphs, we notice it looks similar to that. And so if you look at the absolute value, it has a vertex at 0, 0. And now it has been shifted to this place, okay, to this place, which has coordinates +3, -2, which means it has been shifted 3 units to the right, 2 units down. So the way we write it with the vertex is that y is the absolute value of x minus 3 minus 2. However, because we don't know if this is going to stay the same, it gets closer to the y-axis or away from it, we put an a in front of it. We need to calculate that. So this comes from the fact that we know this is the vertex. Now what do? Pick any point you want on the graph, but easy points. For example, this is 1, 0. This is 0, 1. So you can pick one of those points and plug it in and calculate the a. Okay. For example, if I pick the x-intercept at 1, 0, okay, that means replace the x with 1 and y with 0. That's the meaning of it. So y is 0, x is 1. 1 minus 3 is -2. Absolute value is +2. So this is 2a minus 2. And I hope you see a becomes 1. So replace the a with 1 and you're done. Here's what you should do when you come up with the answer. You really must check. The best course of action is to check with some other points. For example, this point, you plug it in, make sure it works, or pick another point somewhere here. Pick any point on the graph, this should work. How do I mean by that? For example, if x is 0, what do you get? Absolute value of -3, which is +3 minus 2 is 1. So it checks. But don't take a chance, check with a couple more points. All right, now we have this function. And we have one of those essential functions. And I hope you recognize this is y or f of x equals square root of x. You should recognize that. That's why we should be familiar with those. And as you can see, for example, this point, the x-intercept is located at 0, 0, and now it has a different location. And you want to write the new location, namely -3 minus 1. So here's the original one, and here's the new one. So it's been shifted accordingly. And so when we go to this function, again, we are looking at this function or this one. Now we put the a in front of it, and it's been shifted 3 to the left, 1 down. So 3 to the left means plus 3, 1 down means minus 1, as follows. X plus 3 minus 1. That's the meaning of the shifting. And now you pick an easy point to plug in and find the value of a. For example, you should clearly see this point has coordinates what? Negative 2, 0. So if I replace the x with negative 2, this should become 0. I can calculate the a. So when we plug in negative 2 and 3, they add up to 1. And it comes out as 1. A minus 1 is 0, therefore a must be 1. This means a must be 1. So it's y or f of x equals square root of x plus 3 minus 1. And you can pick another point, easy point. For example, I believe this point has coordinates 1, 1. So if you plug in 1, you get with 3, 4. Square root of 4 is 2. 2 minus 1 is 1. So that works. We are in good shape. So it should work. Okay, class? And you should always look for easy points, something that you can easily read from the graph. Okay. The following function was graphed by applying transformation again to one of those functions. And I hope you recognize that this is y equals x squared that has been somehow shifted. So it's been applied to that function because we know those essential functions, elementary functions, toolkit. There are different vocabulary. Toolkit, essential functions, elementary functions, basic functions. So this one, we know the graph looks like this. And the vertex is located at 0, 0. And now the new location is negative 1, positive 2. So the vertex, which was originally located at 0, 0, has been shifted to negative 1, 2. So negative 1, 2, that means we're going to write y equals a times x minus h quantity squared plus k. I hope you remember that also from elementary algebra. So that means minus negative 1, which makes it plus 1. And then this is plus 2. And again, pick an easy point. You can clearly see this point that has coordinates 0, 1. So you can plug in 0, 1, which means replace the x with 0, replace the y with 1, and find the missing a. Obviously, this is 1. When you square it is 1. 1 times a is a, and basically what we have is a plus 2 is 1, a becomes negative 1. So replace the a. So the function of interest is minus the parenthesis x plus 1 quantity squared plus 2. Now, if you, for example, pick this point, which has coordinates 1 and negative 2, so if you plug in 1 here, you get 2, square root is 4, with the negative in front of it, minus 4 and 2 minus 2, that works. So again, an easy point such as, let me just, this one, would be a good pair to check. Again, always go with easy points. We don't want to take a chance. Find the equation of a function that is finally graphed after the following transformation are applied to the graph of y equals x squared. So this function, we're going to shift it to the right by 3 units. So it becomes x minus 3 quantity squared. We're going to reflect it about the x-axis. So we put a negative in front of the whole thing. We're going to bring it down by 2 units. So negative 2 added. So we put negative 2. So the concept of transformation, as far as basic transformation is concerned, if we understand, we are in good shape. Let's look at the definition of extrema. Absolute, also known as global extreme values, or extrema, are either maximum or minimum points on a curve. Extrema is the plural of the Latin extremum. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. So the concept of an absolute means in the entire domain. As you can see, this point, first of all, this is a local mean, local max, local mean. This local mean is also an absolute mean because no other point has a smaller y coordinate. That's the reason. Absolute max occurs at the point C if f of c is larger than or equal to f of x for all x values in the domain. So local max, local mean, local max. This local max is also an absolute max because no other point has a larger y coordinate. Local or relative extrema value. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of a to b in the domain of f of c less than or equal to f of x for all x values in the open interval. As you can see, this is a local mean, this is a local max. Why is it local? Because this will continue, so there are points less than that. Why is this local max? Because this continues, and there are points that are having larger y coordinates. A local maximum is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of a to b in the domain if f of c is larger than f of x for all x values in the open interval, in some open interval. So local mean, local max. So another thing that I want to quickly recap, I want to go over all those graphs. Local mean, local max, local mean. This one happened to be absolute mean also. Local max, local mean, local max. This local max is also absolute max. Local mean, local max, local mean, local max. Peaks and valleys. Peaks are the max, valleys are the mean. Also, this concept of extreme value theorem, if f is a continuous function whose domain is a closed interval of a to b, then f has an absolute max and an absolute mean on a and b. It could happen at the endpoints. The endpoints can only be absolute, they can't be local. So what do we mean by that? Let's answer it quickly here. We want to use the following graph to answer the following. Estimate the interval where the function is increasing or decreasing. So first, I want to remind everybody of those definitions. A function f is increasing on an open interval of I if for any choice of x sub 1 and x sub 2 in I with x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. And it's decreasing in an open interval if for any choice of x sub 1 and x sub 2 with x sub 1 less than x sub 2, we have f of x sub 1 larger than f of x sub 2. And it is a constant in an interval of I if for all choices of x in the interval of I, the values of f of x are equal, they are not changing. So what do we mean by that? I want to make sure that we understand it in a very simple language. As we go from left to right, everybody knows x gets larger. If the y value gets larger also, we say it's increasing. As we go from left to right, as I mentioned, x gets larger. If y gets smaller, it's decreasing. One simple example for each one. For example, for this one, remember the line with a positive slope. For this one, remember the line with a negative slope. Okay, and a constant, that means a horizontal line. This means really a horizontal line. So just for the sake of argument, if we were thinking this as a line, I hope you see this is a line with a positive slope. This is a line with a positive slope. You see that? That's the concept. I'm going to erase the mess, and we're going to go over the answer. So where is this function increasing? The function is increasing here, right? And it's increasing here. So that means from -8 to -4 is increasing from 3 to 7. So that's the meaning of it. Where is decreasing? The function is decreasing here, which means in between, from here to here, from -3 to +3. Now, in MOM, in my open math, they may use brackets. In many texts, the endpoints are not included, but if they included in those, so be it. Determine any local max or mean. Here's a local max. Let me just again erase this so you can see that. Here's a local max, which has the y coordinate of about 50 at x equals -3. Now, you want to answer the question the way they ask you. So if they said, give me the maximum or minimum value, you give the y coordinate. If they want the location, you may have to give them x or both the x and y. So what is the local mean? Right here. This is the local mean. The y coordinate is -50. The way you write it, local mean equals -50, the y coordinate, at this pair or at x equals 3. What about the absolute max? It's important to know that the endpoints, for example, this one, can it be local max? No. Can it be local mean? No. If it is anything, it's an absolute. If this one is above every point, becomes an absolute. Otherwise, it's nothing. If it's below everything, becomes an absolute. Otherwise, it's nothing. So absolute max is equal to the y coordinate of this point, which is 150 at 7, 150. This one, below this, there's no other point. So that's the absolute mean, equals about -225 at the pair -8, -225.